Okay, organic synthesis. So this is the topic where a lot of chemistry students suddenly find themselves getting a headache because we start to put together all of the reactions you know about from your organic topics and decide to make new molecules with them. Um, Now, when I was thinking about making this video, I was worried that people, like students, might worry about why we're doing this. Why do I need to know that for this reaction I need some acid, for this reaction I need a haloalkane of some kind. So what I did was I got in touch with a contact of mine who's a postdoctoral researcher at Manchester University, who works in this kind of field. And I told him that I was about to teach this and asked him to send me something that he's currently using in his research group. So his research group are involved in making molecules that can link together like the rings in a chain. So molecules that are stuck together but not actually bonded together. So that's quite interesting. And what he sent me was to make a bit of one of these molecules. So he sent me this scheme, which I'll give you a moment to look at. But what this thing is showing us is how to make this molecule that's been called fragment C. So personally, I have no idea what they're going to do with fragment C, but I can guess it's going to involve attaching it to fragment A and fragment B to make one of these molecules that can stick to another molecule in a chain. So let's have a quick look at some of these things. Obviously, a lot of this we're not familiar with. But we start with this. That's maybe something these chemists can buy. We do this process, which we don't need to know about. That makes this. Then we do that to make that. And then this one, you don't need to know this, but you might be able to tell me something about what the word E-selective might mean here. If you look at what happens from this to this, we do an E-selective something. Oh, and here we do a reduction. Hooray, we know all about that. So that's good. That's something we know. Here we do a protection and inversion. You don't need to know what those are, but if you look very carefully at this and this, you might be able to guess what that word inversion means. And here is something Z-selective. Okay, so we've seen E-selective and Z-selective. Again, you might know something about that. Now this one I do want you to look carefully at. To go from here to here, we do some elimination. That is an elimination of an alcohol to form an alkene. Look back in your alcohols booklet to see that. This OTS group here is going to behave a lot like an OH group. So let's pretend that's an OH group. Look what's happened over here. Okay, so this is a synthesis, a contemporary one that scientists are actually using. So there's a couple more things I want to think about here. One thing that these chemists are going to need to know is, can they convert as much of this as possible into as much of this as possible? They ideally want a 100% yield. They're probably not going to get that. They're probably going to get more like at most 90%, because you don't get things going to completion. They're expecting to get 90%, and that's assuming that they don't make any mistakes, like forgetting to tighten their round bottom flask and having it drop on the desk or something like that. So they're hoping to get about 90% out of that. That sounds quite a lot. So say we put 1 mole in there, we're going to get 0.9 moles of that. However, when you look at this, we've got loads of steps, like 7 steps. So we're then going to have another 90% conversion over here. And we're only going to get 0.9 of a mole compared to that one this time, so 0.9 times whatever we got there. Mathematicians, you should be able to see that if we do 90% of, say, 1 mole times by another 90% again, times by 90% again, by the time we've done this big long synthesis and got down to here, we've actually lost an awful lot of material. So we might be down to like almost 50% of the moles we started with up here. So what chemists need to be able to do is they need to be able to design a way of making something like fragment C in as few steps as possible. They don't want loads and loads of reactions. Presumably, this is a good example here. Other things that we need to think about. I'm showing you this to show you why it's important a chemist has this skill of being able to suggest reactions, suggest ways of making things. So this friend of mine sees these molecules all the time, and when he looks at this, he needs to have an idea in his head of what is it going to look like in the laboratory. So as soon as he sees the word reduction, he's going to need to think, okay, maybe I need some sodium borohydride or something for that. And then another part of his brain is going to think, oh, maybe I need to go and speak to my technician and ask, have we got enough of that in stock? Or else in 3 days' time, when I get to this point, I'm going to have to stop, and my supervisor is going to be very annoyed with me. So a chemist needs to be able to look at this kind of thing in the way, say, a TV chef looks at a recipe. They need to understand what actually doing these reactions is going to involve. And that's a skill that you can now develop. That is a skill that, you know, the physicists don't do this, the biologists don't know how to do this. This is a skill that chemists learn, and it's really important. So don't think this is just some sort of, let's revise all of those mechanisms again. This is an important process. So that's one from industry, and it looks remarkably like one from your booklet. Okay, so it's the same kind of thing. This comes from the booklet. So regarding what I think we should do to start this topic, obviously a lot of it is going to be looking at your old booklets and remembering how to do the transformations. You could start by writing out a few of the types of compound we've met, and maybe see if you can draw some arrows between them. So maybe if you look back at the haloalkanes topic, maybe you can tell me the conditions and things needed to go from that to that. So you can think of this as a sort of starter. You could spend 10 minutes writing those words out and just seeing what you can remember. But let's look at some of the examples in the booklet. I'm not going to go through a huge amount of the new theory as such. Let's have a look at some of the questions from the booklet. So how do we cope with these sorts of questions? This is on page 3, and if I get my pen, it looks a bit unpleasant. So have a little read, maybe pause the video. But we are trying to make this, and we're starting with this. Okay, and we need to outline a few steps for that. Now, I'm going to give you 2 hints in this video. The rest of the resources you'll be able to see, but 2 hints. One of them is, if I change color, we've started here with something that has eth. You don't need me to tell you how many carbons that is. We've ended up with something that is bute. So there's one reference to a number of carbons there and one reference to a number of carbons there. Big clue, we've increased the number of carbons in the molecule. There's very few ways of doing that. And one of them is to use the cyanide ion. So there's a reaction that could be involving some cyanide here. So now we've seen that clue, it's hard to work out what's going on for these big long names. So let's draw them. I haven't drawn it. I've actually Googled it. So that's why it looks a bit funny. But there's the target. It's often good to start by thinking about the target. And there is what we're starting with, the ethene. So ethene, by the way, not ethane. You can't get very far with alkanes in this process. So we've got 2 carbons there. And those, I give you a clue, are still in my molecule. They're there. I've somehow stuck something, and as I say, you could be thinking about the cyanide ion here, on the edges there, by doing a couple of reactions. So, you could be getting 1 mark here for suggesting somewhere in this process the correct way of adding the cyanide ion to something. And if you look in the front of your booklet, you'll see some answers to the starter I've just given you. You'll see a big scheme. If you look for the cyanide ion making something longer, that will help you to do this part. That's all I'm going to say about that for now. Another one to talk about, another hint, because I'm jumping specifically to the ones where I can give you hopefully a useful hint here, is on page 5. So this time, there's a different tool we can use. Now, again, ethane, there's some eth. Oh, let's use the same color. Let's be consistent. So eth and prop. Okay, so instinctively, we might be thinking, let's do the same thing. Let's add a new carbon onto this. However, this name is different. This thing here, N-propyl ethanamide. Well, we've gone from having something that only needed one number of carbon atoms to something that has two distinct units containing carbon atoms. So a prop, oh, and look, an F. So something different is happening here. It's also contradicting something I said a moment ago. Well, that's okay. Let's talk about that in a moment. Something different is happening here. This means that we're going to have to either use our carboxylic acids chemistry or our amine chemistry or a combination, because look, we're going to form an amide. So sticking two different units together like this, we're going to need to be thinking about those two topics, possibly. Carboxylic acids are going to be our friends here, making amides or making esters. Okay, the other thing, contradicting what I just said, there is one. Let me double check that. Let's have a look at my scheme. I'm afraid I haven't given you a copy of the scheme. But alkanes don't do very much. But on the inside of the front cover, when you look at alkane, you will see the free radical substitution mechanism. So maybe that could be another clue for you to think about. Alkanes don't do much unless we're going to do that free radical substitution. That will convert that into a haloalkane, and that will be useful. You'll notice I haven't given you this molecule. Be a good exercise for you to draw that now by looking back at how to draw amides. Okay, thanks for watching.